Hello. For our engineering design and development project, we decided to tackle the problem of cars piling up in the snow. My name is Nathan Belzel.
I'm Andrea Gandhi.
And I'm Andy Kern.
We have a quick video to show you of an accident that caught our eye early on in this class. After watching the video, we decided to start the engineering process and devise a problem statement. The lack of visibility in snowstorms prevents drivers from seeing oncoming accidents. Anyone who has traveled by vehicle in snow has experienced the difficulty of driving in low visibility. Taking place in regions that accumulate snow, typically the upper Midwest to Northeast regions, 17% of all car accidents occur in these conditions, which are largely caused by low visibility and lack of car control. The combination of reduced friction on the ground, precipitation on the windshield, and concentrated water droplets in the air decreases visibility on the roads. These factors contribute to car pileups, which is when oncoming traffic is unable to see a danger focus in front of them, resulting in multiple cars crashing into one another. Though human behavior plays a large role in these accidents, the limitations to human abilities, such as an inability to see clearly in the snow, is a main contributor to major car pileups. The team intends to make a product that makes motorists aware of oncoming crashes or vehicles.
To continue our research, we took a look at some existing solutions. The ones that we researched most in depth are road flares and cell phone alerts. Although these can be useful, they don't work well for our problem. For example, road flares take time before you are able to use them, time which is very precious in our situation. For cell phone alerts, although they are real-time user submitted, they simply don't work in the sense that visibility and distraction are the main problems in our scenario. We also looked into some existing patents. We had sort of two different camps in this aspect. For one, we had more complex radio systems that also utilized GPS technologies. On the other hand, we had a more low-tech solution similar to the way road flares work. Also, here are some visuals of the existing solutions.
So, after our research and making a design, we decided that our first solution would be a radio system that consists of a transmitter and a receiver. And basically, cars that are crashed up ahead would transmit a frequency to oncoming vehicles, which would detect the signal by having a receiver. This would be a two-part system in which it could be turned on manually or automatically, and the power would be derived either from the car or from a battery. It's important to note that during severe accidents, emergency vehicles will be notified of the crash because an airbag will be deployed, which will send off a signal to the emergency vehicles.
So, that was a lot to take in, and it's understandable to not be able to entirely visualize what our product looks like or how it will work. So, we decided to make a flowchart. So, starting off, the product is turned on during a snowstorm. For our initial thought, it would be unfeasible to have this product running at all times, and it would probably just take energy from the car battery that's not necessary. So, once it's turned on during a snowstorm, the user tunes into the crash alert frequency set by maybe on a state level or on a nationwide level. We weren't at the point of fully deciding on that quite yet. And then we would go into a decision. Did someone on the road get into an accident? If yes, then the driver would pick up that signal from their car, and they would make the proper adjustments to their driving style to make sure that they wouldn't add into that accident. If no, then the question must be asked, did the driver themselves get into an accident? If yes, then another question has to be asked, did the airbags deploy? If they did, then a lot of what just happened is out of the driver's hands, and the reaction to it is also out of the driver's hands. What should be important is their health and safety. So, we are going to try and take the wheel from them a little bit and try and fix the problem. So, first, we will alert the proper services. We would call 911 and alert them of the GPS location of the driver. And then we would automatically turn on our radio system, meaning the transmitter, and it would automatically start to project that frequency. So, there were some questions about how we would use this radio info and see if we would actually be breaking any sort of laws with this sort of plan and see if there'd be anyone's toes that we're stepping on. But there are some frequencies that you can use freely. You just have to pay for the license, which is usually a $70 fee to try and get that license. and use channels from 462 megahertz to 467 megahertz, which can be pretty useful.
We also took a look at ham radio technology, and we were interested in this because it is available for private use. However, to obtain a ham radio license, you have to be well knowledgeable of radio technology and pass a test. We also wanted to put the receiver in a shielded location underneath the hood of the vehicle, so that way if it were in an accident, it would not be deformed in any way. And lastly, we wanted to have the audio alert the driver through the vehicle's speakers as opposed to from the receiver itself.
So, as part of the engineering process, we have to sometimes recoup and think, is this the best way to solve this problem? And after meeting with an expert in a lot of the things that we were trying to talk about, we found that a lot of what we were doing was either unfeasible or not the best solution. There were parts that we decided to keep, but we decided that we needed to change something a little bit.
So after our meeting with Aaron Tarlow, we decided to introduce the MoDOT camera system. And basically, MoDOT cameras are placed all throughout Missouri highways, and Missouri officials monitor highway activity through these cameras. So we would want to project a frequency from the MoDOT camera, which would be through an IR LED that is mounted on top of the camera, to vehicles throughout the highway to alert them when there is an accident up ahead or when there is an accident up ahead. This system is much more simplified than our first design, which included communication between multiple cars, and now we have communication between an individual car and a MoDOT camera.
To help you visualize our design, we've included a diagram of our proposed solution. First, a MoDOT employee sees the crash via their cameras. Next, they press a button which alerts the drivers in the surrounding area through IR frequencies. After receiving that frequency, oncoming drivers will hear an audio message alerting them to the crash ahead.
So with the new product, we decided to have a new flow chart. So the car started and the product is immediately turned on. There is only the receiver part in this car, so it would make sense to always have it on just in case. This could possibly be used outside of just snowstorms. So, and it would take power from the car battery. We have that fully decided at this point. Then the monitored MoDOT camera system, MoDOT being the Missouri Department of Transportation, they would be monitoring for accidents as they always do. And then if an accident were to occur, then they would turn on the IR light. Or if there's oncoming construction, then they would turn on the IR light. Or even emergency services, they would do the same. For all of these, there's a set frequency that would be put out by the IR light. And each receiver within each car would be able to tell exactly what's going on, and they would play a short audio message on the car's sound system to try and alert the driver of what's going on.
With the new design, there are several benefits. The first being that there is less reliance on the universality of the product, meaning that not everybody has to have this product for it to function properly. Because in the previous solutions, the communication was between multiple cars, so if not everybody had the system, it would not work. But with this system, the communication is between an individual consumer and a MoDOT camera official. Also, we have a better understanding of who we're marketing to, because in previous solutions, it was a widespread target market. Now we know that we're marketing to MoDOT and drivers in Missouri. It's also much easier to explain, and it's easier to manufacture. And lastly, it's easier for us to understand given that we have relative little knowledge of radio technology.
Our next steps at this point are to finish researching our components as well as laying out a preliminary prototype design with the given components. Next, we would start constructing our first prototype with the IR technology. After that, we would test, make the necessary adjustments, and continue until we have the design that we like. At this point in our design process, we still had little to no experience of coding and electronic circuits. However, in our research process, we soon learned the basics.
We've begun the prototyping and testing stage. So we started out by designing a simple circuit on multi-sim to help us visualize where we want to go with our product. As you can see, there is an IR LED and it sends a signal to a phototransistor, which then sends a signal to an audio projector. And there's obviously much more detail to this, but the main point is that an audio noise would be projected to alert the driver. Okay. As we've developed our design, we also want to think about our marketing plan. And assuming that MoDOT would agree to work with us on this product, because we have to assume on some level that they would, we want to sell it in two different ways. One is to the average consumer with a final car, and the other way is to manufacturers who would implement it into newer cars. And assuming we could get an IR LED, Opticom actually sells 3 available models, and it depends on whether or not they would sell it to 3 high school students, but because it depends on whether or not they would sell it to us students, because most of these IR LEDs are sold to emergency or priority vehicles.
So, going forward with our process, I think that we have to disclaim a couple things about working with the government in general. There's a legislative process that may lead to this product may not being feasible. For example, MoDOT would probably have to front the capital cost of implementing all the IR lights. It's possible that they wouldn't want to front that cost if there wasn't a level of universality guaranteed. And the only way we can guarantee that universality is if it is possible to make these IR receivers mandatory in every car. And that would be a very hard thing to decide on, and something that we'd have to leave up to legislative bodies. So we are incredibly proud of the work that we've been able to accomplish this school year, given everything that has happened, and given the circumstances of our learning environment. But at the same time, there are certain things that we wish we had been able to do, and if we chose to continue this product and its development further, here's what we would do. We would finish our prototyping and testing. We would have conversion of a circuit board to an Arduino board, meaning soldering, and we would start communication with MoDOT in a very real sense to try and actually get this started up. And we would fully devise our marketing